today we are going to understand and we are going to see about a module that we call is a basic concept of remote sensing. So under this title we will be trying to see how the remote sensing come into picture. Before the remote sensing, you must have learned in other modules about the photogrammetry, where the people were using aerial photographs taken by aerial cameras, by using the aircraft, where we were assessing, we were trying to understand, we were trying to map the different land surface features, both human as well as the man-made as well as the natural features. But the remote sensing that came little late after the photogrammetry, that was in the picture for maybe for 100 years, because the very first aerial photograph that what we find was done by a gentleman that he called is a Felix. He thought of why not to take the aerial photograph instead of manually making and surveying a particular part of surface of the earth. So what we have that must have taken up by some other resource person differently in a different module. But today our concept is, our issue is to understand the fundamental concept of remote sensing. Now let me give a proper definition of remote sensing. So as per American Association of Photogrammetry and Remote Sensing, that was American Association of Photogrammetry and Remote Sensing, they gave a formal definition in the year 1988. And as per this definition, if we try to understand the remote sensing is nothing but is an art and science of acquiring reliable information, measurement by use of remotely sensed data without being in physical contact. The moment I say is art and science of taking measurement by the use of satellite remote sensing data, and that too without being in physical contact of it. Now let me explain a little bit on art and science. The moment I say art, that means how beautifully, how nicely you are making a map by using satellite data. The moment I say science, that means how accurate, how scientifically perfect you are taking the measurement of what? Both features, that is the earth surface features, that means how accurate we are trying to acquire the information. The moment I say art and science, now let us understand science. How accurate we try to acquire, how accurate we try to get the information, both in terms of hypsometric and physiometric. That means in terms of true shape, size of the physical as well as natural feature of the part of surface of the earth. That means how accurate, how close to the ground reality we try to acquire the information. Because the issue is that when we want to plan for any area, when we want to have a development of a particular area, we need to assess, we need to map, and we need to see what all is and where it is and how much it is. So what, where and how much. So to answer these three questions, we use the remote sensing satellite data. So that is the beauty of satellite data. Now in this module, friends, we are trying to understand how the data is being acquired, what is the uses, what is the advantages, and so and so. Now today everybody is talking about remote sensing. Whether you talk about the people from engineering, people from geology, people from geography, people from other disciplines, everybody is talking about remote sensing. Now this word is so catchy today, so let us understand, let us see what is the beauty, what is the advantages of this particular remote sensing technique. Now there are several advantages. To list few, I must tell you that earlier to prepare any map of any particular part of the surface of the earth, there was n number of people involved. It's a long time and it's a tedious job. The Survey of India topo sheet that has been prepared, that has been made, and different scale, 1 is to 12,500, at 1 is to 25,000, at a scale of 1 is to 50,000, at a scale of 1 is to 2,50,000, 1 is to 5 lakhs, and 1 is to 1 million. Survey of India has made beautifully nice maps for whole of the country, but that was made long back, maybe say 50 years from now, maybe 70 years from now. Today we do not have another second map of the same particular part of the surface of the earth, and in that 50 years or 30 years from now, what we have, lot of changes we observe on any particular part of the surface of the earth. So the very first advantage is that when we talk about the remote sensing is a repetitive coverage. Repetitive coverage of the whole part of surface of the earth. Coverage of whole part of surface of the earth. Now different countries have different survey agencies. They survey their own particular part of surface of the earth. But this remote sensing, what we have, they do not see any particular boundary of any country, but it covers whole of the earth surface. So repetitive coverage, that means if we draw here the earth, what we have, this satellite moves from pole to pole, and therefore we call it a polar orbiting satellite. It moves from pole to pole in fixed orbit, whereas the earth rotates west to east, we all know, and it also revolves in its orbit. So once it rotates, it covers certain portion of the earth's surface, and then when it moves earth little bit towards east, then satellite again comes back to another part of surface of the earth, and then it captures the whole part of surface of the earth from pole to pole, that is from north pole to south pole. So therefore it is a repetitive coverage. Some satellite comes at the same part of surface of the earth every 12 days, some comes after 14 days, some comes after 22 days, some comes after 3 days, and some comes even every day. That we will learn in a later module. So this is one of the very important advantages of satellite data, that is repetitive coverage. Second is that of what we have, it scan, it sense a particular part of surface of the earth beyond the visible region of the electromagnetic spectrum. Now to understand this topic, let me tell you that our eyes, which are sensitive to only the visible region of spectrum, that is the region that we have the blue, green and red. But what we have in remote sensing, we have different sensors. Sensors we will learn in another module is an optical mechanical device which detects the sun's energy in different region of spectrum. That is beyond visible region, that is the thermal region, we have the microwave region, and so and so. So this is another beauty, that we can see the different part of surface of the earth in different region. So any particular feature or object which is there on part of surface of the earth, if we do not see, if we cannot see that by our naked eyes, but the satellite can see and detect and analyze and map. So this is another very important. And the third is, it has multiple scale, which is very good for different application. As I said that topo sheet has been drawn, has been made at a fixed scale. But if you want any object, any feature that is to be mapped on another scale, you do not have that option. But here what we have, the satellites are scale free, it has a pixel. So what we have, if you want to draw any information at a scale of 1:4000, you can get it. If you want to draw 1:2000, you can get it. But earlier, when we are using Survey of India topo sheet, we do not have that kind of map. So this is another big advantage of using the satellite data. Now another very important advantage of using the satellite data is a day and night operation. That means data can be captured in the daytime and also in the night time. It's a all-weather operation. That means you can capture the data when there is sunlight and when there is cloudy cloud cover. So that means for that we have a different types of satellite data. You will learn that in a different module. We call it the active remote sensing data, and second is called passive remote sensing data. So the moment when we use the sun's energy to capturing the information of certain part of surface of the earth, that data is called the passive remote sensing data, and second is active remote sensing data, lidar data, radar data. They will have a separate module for that. So this is another very important uses of or advantages of using the remote sensing satellite data. Now another very important issue of using the remote sensing data is a synoptic coverage. Synoptic coverage. So what we have is that the sensor remote sensing satellite passes and it covers the energy which is being reflected back at the sensor by different objects. So what we have, it covers certain portion of surface of the earth, that is synoptic coverages that we call. So what we have in surveying, we need to have different people, you need to have a different traditional technique like plane table, prismatic compass, theodolite, sextant and all. But what we have here is, we have the satellite which are orbiting over the surface of the earth at an altitude of somewhat from 650 to about 750 kilometers above the surface of the earth, and it continuously capturing your data. Another very important advantage of remote sensing, or rather the most important, is the cost and time. Cost and time. That means in today's fast development of the whole part of the world, in any country, people do not have time, but they have the money. So it is in two ways. It is advantageous in terms of time and the cost. In a very low cost, you get the data of your particular part of surface of the earth, and in less time. Earlier, as I said, that the topo sheet, to prepare a very small square kilometer area topo sheet, it takes several years. But now today, you just order the data of your particular area, and that you get in couple of weeks from agencies which are responsible for acquiring the satellite remote sensing data. So cost and time is very important when we are talking about the remote sensing. Therefore, this advantage is coming up very fast, and because of that, acceptability and the use of satellite data is coming in the different domains of today's world. Now let us understand the milestone in the development of satellite remote sensing, and that can be clearly seen in table 1. Milestone, that is a historical development of remote sensing, where we see in the year 1687, where the Newton's Principia basic law of mechanics was developed. In the year 1826, Nepes' first photograph was developed. In the year 1958, Turachon's aerial photography from balloon was taken up, and later on in the year 1903, Wright brothers developed the aeroplane. So from then onwards, they started taking the aerial photograph by using the aircraft. In the First World War, photo reconnaissance was made. Similarly, if you see, keep going, in the year 1959, first space photogrammetry by Explorer 6 was done, and it was the year 1972 when the Earth Resource terrestrial satellite was launched, that we call as ERTS-1, and later it was named as Landsat 2, that was done in 1972. That means from 1972 onwards we started using the satellite data, we started getting satellite data. In the year 1982, thematic Landsat mapper was launched with the Landsat 1 remote sensing. In the year 1991, European ERS-1 was launched, and in India the remote sensing came little late, that was in the year 1988, where IRS-1A and 1B was launched. Similarly, we keep going and we have latest developments. Say for example, in the year 2005, Cartosat 1 was launched, and the year 2007 the Cartosat 2 was launched, and the most important and the best satellite data that was launched a couple of years before, that was WorldView data, that was in the year 2014. Now let us understand the basic concept of remote sensing data acquisition. Remote sensing data acquisition. Now what happens? Here we have the sun, which releases energy in all the direction throughout the year, day and night. This energy travels in the form of wave, and it reaches a particular part of surface of the earth. Now what happens when it reaches this part of surface of the earth? What happens? It immediately reflects back, and some of the energy is transmitted in the material and some of the energy is absorbed, and later on slowly it emits, and that energy goes to the atmosphere. So in remote sensing, that we call is optical remote sensing, where we use the sun's energy that acquires the data only at the daytime. What happens? It reaches this energy at the satellite. At the satellite, which I told you is at an altitude of about 750-650 kilometer, something like that. It reaches this energy, and at the satellite we have the sensors, which records the reflected amount of energy, and this sensor, what happens? It further transmits the data at the earth station. So there are different earth stations with huge antenna. They record the data that is sensed back from the satellite sensor to the earth station, and from the earth station that data is stored, put in an archive, and that is there for dissemination, and for the people, they can get those data from those agencies. In India, we have the agency that is called Remote Sensing, Indian Remote Sensing data that can be acquired from NRSC, National Remote Sensing Center, Hyderabad, and Earth Station that is there in the Balanagar, which acquires the data, both Indian data as well as the United States of America data as well as the French data. So what we have, as I told you, that for the very first time it was American agency that launched Earth Resource Terrestrial Satellite 1, and then it get converted into Landsat 1, that was renamed as Landsat 1, 2, 3, 4, 5. We have series of satellite. Similarly, Indian satellite, we have Indian Remote Sensing Satellite 1A, 1B, 1C, 1D, like that. Similarly, we have the French data, that we have the MODIS data. So all these data can be acquired by putting indent from the National Remote Sensing Center, Hyderabad. So these are the basic data acquisition, how it works for a general layman to understand how this science works. Behind this, there is a lot of science that we do not need to know as a user. We are using as a geography student, as a geology student. We need to acquire the data from this agency, and then we can use for different application. Now let us understand, as I said, that sun's energy comes and reaches the surface of the earth. It travels and comes at the surface of the earth in different spectral region. This is a spectral region. This is a natural existing spectral region. As I said, the visible region, on the left side of visible region is X-rays, Y rays, gamma rays and so and so. This is a short wave region. If you go right side to it, visible region, we have the infrared, microwave, then we have the radio wave, and then we have the thermal and so and so. So if we see this extension of this visible region, we have the blue, green and red, which extend from 400 to 700 nanometer, or in other words 0.4 micrometer to 0.5, 0.6 and 0.7 micrometer. So in this region, whatever the sensing is done by the use of satellite sensors, that we call the passive remote sensing sensor, where we have the daytime operation, whereas we can go right side of it, we have a thermal and microwave data. So this figure clearly explains the wavelength range of electromagnetic spectrum. Now if we see the figure 4, now another very important issue is to understand the spectral signature curve. What we have, there are different objects on the surface of the earth. We have the water, we have the grasses, we have the soil, we have the moisture in the soil and so and so. But what we have, when the sun's energy reaches the surface of the earth, it behaves differently in a different spectral region. Say for example, water in blue region does not reflect more. On the left side we have the reflectance. But if you go to green region, it reflects more, but if we come to the infrared region 0.7, the reflectance is almost 0. But at the same time what we have, if you see the vegetation, what we have, it reflects less in the blue green region, but strongly behave in the infrared region. So therefore, in order to understand, in order to assess, in order to map the vegetation cover, we can take the satellite data of infrared region. So what we have, this is a spectral reflectance curve, standard spectral reflectance curve. Now friends, let us understand how a particular object looks in different spectral regions. The figure 5 shows that there are 4 spectral bands of IRS, Indian Remote Sensing Satellite data. It has a sensor list 3, multispectral images, that is a different spectral region that shows different spectral characteristics on the ground. Now if you see the green band, which extends from 0.5 to 2.59 micrometer, what we see, this is a lake which is giving a light tone. If you go to red band, which extends from 0.62 to 0.68 micrometer, it is little bit darker, grayish. But if you come to near infrared red band, which extends 0.7 to 0.86 micrometer, the water looks clear cut dark black. But if you go to short wave infrared band, which extends from 1.55 to 1.70 micrometer, it looks completely black. So what do we have, that if you want to identify a blue, you need to take near infrared band or short wave infrared band. Similarly, if you want to identify the vegetation cover, then we need to take infrared region band. So in different bands, there is the same area picture. All these 4 pictures are of the same area. But the point what I am trying to make you clear is that how it looks like. This particular part of surface looks in the green band like this, in the red band like this, in the infrared band like this. This is what I said in the beginning, that is one of the most important advantage, that we cannot see in the near infrared region, but the sensor, we have designed a sensor which can detect the sun's energy in this particular band, and therefore if we see these 4 objects, the clarity of identification and separability of different objects are quite clear. Now friends, under this module, that is basics of remote sensing, let us understand the 4 very important issues. That is also very important in the sense that as a layman, as a common citizen, if you want to use any satellite data, which data you need to have, what kind of data you need to have for what application. This I am going to explain to you, and I will make you very clearly understand. And for that, what we call is the sensor characteristics, that we call is the sensor characteristics. That means there are 4 sensor characteristics, and the very first and the most important is we call it a spatial resolution. Spatial resolution. Second is spectral resolution. Third is radiometric resolution, and fourth is temporal resolution. So as a user, what satellite data we need? We need to have a satellite data of IRS, Indian remote sensing data, or Landsat, or spot which data from which satellite we need to have. And for that, if you understand these four characteristics of sensor, that will make you to clearly identify and select a particular data of particular satellite. So you can take any of this data from any of these satellite, but you have to keep in mind these four aspects. Now let us understand one by one in each in detail. Now spatial resolution, if I say what is a spatial resolution? A spatial resolution is nothing but is ability to separate, to discrete, and to identify different object. Now if I say in my hand, suppose this is a water and this is a soil. So if you want to separate water and soil, you need to have at a certain distance. So it is nothing but is a spatial distance which separates two different objects differently. So remote sensing satellite data, say for example from sensor list 3, list 4, it has a different spatial resolution. List 3 has a resolution of 23.5 meter, list 4 has 5.8 meter, like that. So if we have a satellite data of say list 4, which is resolution of 5.8 meter by 5.8 meter, so identification separability will be better. But if you have data of 23 by 23 meter, the identification separability will be not so good. If you have data of list 2, which has a resolution of 36.5 meter, so it will be again a data where the details cannot be identified, that cannot be separated. But if you want to do a large scale, large area mapping, you need to have a data of list 3, which has a spatial resolution of 36.5 meter. If you have a smaller area, then you need to have a data at 23 meter resolution. But if you want to do a study at the ward level, at the micro level, you need to take the data 5.8 meter, even better than that we have the Cartosat data, which has a resolution of 2.5 meter spatial. Now figure 8a, which shows a spatial resolution. Now there are four examples. One is 0.6 meter spatial resolution, 2.4 meter spatial resolution, 5 meter spatial resolution, and 30 meter spatial resolution. Now this is of the same area, all these belongs to same area, there is no change. Now you can see 0.6 meter resolution, things are very clear. In each and every tree, small or big trees, and every building can be mapped. But if you come to 2.4 meter resolution, little larger resolution, the things have little bit hazy. But if you come to 5 meter, things are again distorted. You cannot identify each and individual tree. And if you come to 30 meter, it pixelates. So you cannot see any of the object and feature, what all it is. So therefore, this is what I said, that the better the resolution, that means lower the value, better the detail, ground details. So spatial resolution is that ability to differentiate, to extract the information. If you want to extract the information, whether human as well as natural, at a large scale, I mean 1:4000, 1:2000, 1:5000, then you need to have a data of Cartosat or list 4 or any other data. As I said, the WorldView 2 data, even WorldView 1 and WorldView 2 data, which has a resolution of 0.6 meter to 1 meter to 2.5 meter, and so and so. So this is one special characteristic. Now which satellite data you chose, that precisely depends on the spatial resolution. Spatial resolution, that means you need to see how much area you are going to investigate. What is the size of the your study area, how big it is. If it is a big area, if you want to have a less detailed information, then you can take any other satellite data of list 2, list 3, and so and so. Now the second aspect, that is spectral resolution, that is a spectral range. Spectral range, that means visible region 0.4 to 0.7. Within this we have the 0.5 and 0.6 micrometer. So there are three spectral bands. What we have? Spectral bands. There are three spectral bands. Blue spectral bands, blue, green and red. There are some data which takes 4 bands, blue, green, red and infrared. So this is a 4 band data. This is 3 band, this is 4 band. So if you take data in 3 band, the detail separability identification will not be good, but if we take the 4 band data, it will be better. There are certain data where we have the 1 band, that we call is the monoband data, monoband. So monoband means black and white data. So it is something like colorful data, and this is a black and white data. So if you take 1 band data, the detail separability will not be good. I will show you in the figure. But if you take the 4 band data, 3 band data, identification separability will be better. So therefore, spectral resolution is the number of bands in which a particular data has been sensed, and that has the particular part of surface of the area has scanned. Now the second aspect that can be clearly seen in figure 8b, which talks about spectral resolution. Spectral resolution, I said, the single band, monoband, black and white data, which has a range 0.5 to 0.7 micrometer, the single band. But if you see on the right side of this picture, what we have? IRS list 3 multispectral data. What we have? Green band, top layer, red band, then we have the near infrared band, and then shortwave infrared band. So what we have? We overlay all these 4 bands and we get the final data that we call is a false color composite. The third is radiometric revolution. This is another very important characteristic of the sensor, where we talk about the gray values. Suppose if I talk about 1 bit data, that means either 0 or 1. That means either black or white. There is no other tone. But if I take, say for example, 8 bit data, that we call as a 2 to the power 8. So 8 bit data, that means 2 to the power 8. In a common terminology, if I let you understand, that means if I write 2 8 times, so it comes to 2 into 2 4 into 6, like that it comes to 0 to 256, 255, sorry, 255, or we call is a 8 bit data is a 256 gray shades. If we are using single band data, mono data. So what do you see here? Here we have only 2 shades, black and white. Here what we have? A range of shade, gray shades. So what we have? 0 to 255. So here we can identify even the finer changes in the land surface of the earth will be better. If we have a data of 8 bit data in multispectral band like this, 3 band, 4 band data, the same area can be mapped in a color tone. So what we have? It will not be gray, it will be different colors. So again, if you have a 8 bit data, mono data, that will not be so good, but if you have a 8 bit data in multispectral scanner, MSS, so that will be a better data. So this is the third important characteristics of which data we need to choose. We need to choose a data, monoband data, a multiband data. If multiband data, 3 band, 4 band, there are certain data, as I said before, word view 1 and 2, it has 8 bands. It has 8 bands within the visible region. So that means it has been further sliced into thin micro narrow bands. So this is a third important issue that one need to look into when you are talking about the sensor characteristics. And the last is the temporal resolution. As I said in the beginning of my discussion and the lecture, that we have a data which is repetitive coverage. That means in survey from the topo sheet, a topo sheet that has been surveyed in 1971, 75, 96, after that no effort has been made to capture the information from the same part of surface of the earth. But here in remote sensing, what we have, There are certain satellite which comes every 14 days. There are certain satellite which comes after every 22nd days. List 3, list 4, sensor of IRS satellite that captures the same part of surface of the earth again after every 14 days, every 22 days. List 4 satellite which comes after 5 to 6 days. So what we have the beauty, earlier we do not have a data what we used to see in say 1970 and 1990, but what we have of any part of surface of the earth, what we have, we can have data. Suppose today is say for example 20th January, so 14 days, that means on the 4th of February, 3rd or 4th of February, we can have a data of the same part of the surface of the earth. Now the third figure, that is figure 8c, which shows the temporal resolution. If you see this one, 24 days, I said 14 days, 24 days. So if a data is being captured at the 3rd May 2015, another data of the same area we get of 27th May, and another data you get of 20th June. So we get the so frequent data. This is the beauty of temporal resolution. So this is very important and useful for environmental application, change detection, what all has changed. So it depends again on you how frequent data you want to have. Every month data you can have, every year data you can have, and you can see what all changes has taken place. So these are the 4 important, very important, I can put it in a block, very important characteristics. Based on these 4 issues, you can choose your own satellite data, which satellite data will suffice, will fulfill your project objective and the objective of your work. So what we see today, that there is an enormous potentiality of remote sensing data uses in different disciplines that we have. I hope that you could have understood, and you could have got the glimpse of how we can use a particular satellite data for different application. Thank you so much for your patience hearing, and have a good day.